In this video, I'm going to show you my implementation of Ralph, and I have given a lot of time and effort into this, but unfortunately, Ralph loops are a little bit going to be handicapped by the fact that Claude Code is no longer allowed to use programmatic usage on your subscription. Thank you, Anthropic. And also, a lot of harnesses have started adding a /goal command, which in a lot of ways is kind of replacing the old strategy of Ralph loops. That being said, I've given a lot of thought to my Ralph implementation, and I want to show it off and also demo it a little bit, although the demo that I have done didn't exactly go according to plan, and I have a couple of thoughts about that as well. So anyway, this video might be a little bit all over the place. I have 3 different recording sessions that I'm kind of splicing together, so hopefully this makes sense. So first of all, a usage of this project that I wanted to demonstrate is rewriting my LunarVim implementation into what I'm calling LunaVim. For a little bit of context, the reason that I'm doing this is I was using LunarVim for a long time. I made my own fork of it, but unfortunately some of the packages that my fork and the original implementation depend on are no longer maintained, or like things happen such that they're not really my implementation wasn't working super well, so I wanted to rewrite it, and I figured that would be a good use case for a Ralph loop. Now, in my demo, you'll see that not everything worked out exactly correctly, and this leads to one of my main points that I want to make in this video. As I think it's a good idea, a good strategy to generally try to go as many layers of abstraction high as you can as you're using these AI tools. I think you can get a lot more work done and be a lot more productive that way. But I do think that there's kind of this instinct, at least that I have felt in myself, and I think I see generally speaking in the world, whether it be on X or other people on YouTube showing their usage of these AI tools. There's a sense that we really want to optimize the amount that the human is in the loop and I guess take advantage of the human labor as effectively as possible. And I think one shortcoming that I have realized in my own work, at least, of this strategy is that there are some things where it really is most effective to have the human in the loop. So in my demo, I show how to use a Ralph loop to re-implement LunarVim into what I'm calling LunaVim. And one of the main things that I ran into is at the end, it didn't really work exactly as I expected. And what I did is I took that starting place from the Ralph and I basically prompted back and forth a little bit and manually tested, and now it's in a much better working spot. So on the right side of my screen right here, this is my implementation of LunaVim, and I'm looking at it inside of LunaVim. And most of the keybinds that I use are working as expected now. So essentially this implementation was 95% built with Ralph, and then all of the manual testing and prompt corrections I did after the fact. And I have a pretty solid working version of this right now. So anyway, I also have made some changes to the way Ralph works from when I first did the demo to now. So you'll notice here on the side, I'm looking at my Ralph implementation, and you can see the steps. It's a tree. So as you work down the tree, or as Ralph works down the tree, it can take care of different steps. And when it runs into a problem, like this one was skipped, it can go to a different branch. So I guess I'll scroll all the way around. This will be easier. You can see that these tasks are separate in terms of the dependency tree of the features. So Ralph can continue working on these even if there's a problem with one of the branches up here. I think that was how it worked before, but there were a couple of things that didn't seem to work as expected. One way around this, which I'll show in the demo, is that you can have I guess you could call it a sidecar agent that watches the Ralph and corrects for things when things go wrong. But I think this view makes it a little bit more clear about like how the dependencies actually relate to each other. So, and you can see the tree nature of it pretty well down here. So anyway, I will cut now to the other 2 segments of this video, and hopefully it makes some semblance of sense. Thank you for watching. Now, Ralph seems to be a little bit more unpopular these days, but it's something that I still use pretty significantly. So much so that I have my own implementation, which is a Rust CLI, which does a couple things that I'll go into in this video. So this right here is my Ralph implementation. I call it Ralph-RS because it's written in Rust. And there are a couple of things that I wanted my Ralph implementation to do that maybe there are some out there that do this, but I wanted to control my own version of it. So the two biggest things that I wanted to achieve with my implementation of Ralph are I wanted it to be harness-agnostic. So I can use Claude, I can use Codex, I can use an arbitrary one that doesn't exist yet by updating my config with whatever the command is to invoke that harness. And the other thing is I don't want any extra files in my repositories from using Ralph, because I might be working on a code base where people have different processes by which they implement their changes. They might be using different harnesses, and I don't want to have my own dedicated files specific to my Ralph loops that clutter up the repository. So instead of saving plans as JSON files or any other strategy inside of the repo itself, what my Ralph implementation does is it uses a SQLite database, which is outside of the repo, and manages it that way. Now, I do have one really big change that I'm still testing, and it's this pull request right here, which the two things that this pull request does, the first of which is it makes the plans, instead of linear plans, it does a dependency tree. So if there's a branch in the tree and it runs into a hard blocker on one of the branches, it can keep going on a different branch, and you can just answer the question or resolve whatever the blocker is on your own time. And as such, you can get more continuous, productive work out of your agents and harnesses than you would otherwise. The other thing is that one of these commits here, I'm not sure which one, adds the grok harness. At least I thought it was. Maybe not. So this iteration of Ralph is what I will be testing right now in my reimplementation of LunarVim. So for a little bit of context, my favorite distribution of NeoVim is called LunarVim, which unfortunately has been unmaintained for a while now. And I at first created my own fork where I basically just used Claude to update it. And I've run into a couple walls where I think I need a fresh rewrite of it. So I'll use this as a use case where I can demonstrate what Ralph can do. So first of all, we're going to generate our plan, which with my CLI looks something like this. Ralph plan generate harness. I think that's the way it works. Oops, Ralph plan harness generate. So I have Claude configured as my default harness, and I use this harness, which gets invoked with a special agent file, to understand how to create Ralphs. So I will create the plan with Claude, but then we will implement it with Claude Codex, and we'll try it with Grok and see how that goes. Now, for a little bit of context as to what's going on as Claude is configuring this all, if I show what's in this directory, I have my fork of LunarVim, which is ck-lunarvim, which we're going to rewrite from scratch. I just have that here as a reference. I have a plan file, which I generated with Claude. This is going to be essentially a higher level detail of what the Ralph plan is. This isn't strictly necessary, but I made this earlier for the sake of doing this demo. And then a README, which kind of outlines what the idea of this project is. I wrote it by hand. I'm sure it will probably get extended after this Ralph loop runs. As an aside, as we're waiting for Claude to canoodle, I think Claude has gotten significantly worse recently. I think they're really having problems with compute at Anthropic. So I'm looking more and more at switching to Codex and potentially Grok, and I even have ideas of building my own harness. Just to show off Ralph, we're going to go with just the plan description for this question. So it won't actually add anything to the agents.md file, which again, if other users are going to contribute to this and they don't want to use the kinetic context CLI, then that shouldn't be part of the agents MD. So the plan guidance should live in just Ralph's brain, not in the repo itself, which is one of the reasons why I like my own Ralph implementation. All right, so it just created the plan and approved it. So now what we'll do is in another window here in my tmux or pane or whatever it's called, I'm going to run Ralph. And you'll see here's the plan. We have 50 steps, and I can go into the plan and I can see each step. And I can also see that like these two steps are parallel and they both depend on on this first step. So as you get further down in this chain, I can move this window over. You can see how the dependencies of tasks kind of go along with each other. So this is the first time I am trying running with the dependency graph in earnest. I have run one before, but the plan just wrote it all linearly anyway, so I updated the skill to encourage the planner, which in this case I used Claude. The skill now encourages it to use the dependency graph. So anyway, we will go and it should tell me how to run it. Okay, it just says Ralph run. Usually it gives me the Ralph run and then plan name. So I'll just try that. All right, so it kicked it off and now it's going. We're starting with Codex, and you can see when it's done, it should run this smoke test, which this step itself is creating. So yeah, we'll see how this goes. As this is running, so a couple things. You can see the title of the step, the status. You can see how many attempts a given step took, and if it takes more than that amount of steps, then it will stop that branch. You can see the harness that's being used, as well as the tests that will be run deterministically after the step is done, and the total duration and the duration of the attempt that completed the task. So now you can see we're on to the next one, and the time is elapsing. And this one is also done in Codex, but as we go down, we should be able to find some, like these right here, for example, use the Grok CLI. So it'll be interesting to see when we get to this phase 7.2 step, how will Grok perform? We'll see. So I'm not sure how well this will show up on video, but as this plan is going, I have really zoomed out in my terminal. I suppose the TUI interface for this could be better, where I could maybe scroll through the plan prompt, but that's not a possibility right now, so I had to zoom out a lot. But you can see here that the plan prompt, which gets injected into every step, includes how to use the kinetic context CLI to ask questions. So that's how I'm able to inject it into every prompt without cluttering in agents.md or claude.md. The prompts that get concatenated together are the global prompt, which applies across the entire machine, the project prompt, which applies to any Ralph loop run in this project, the plan prompt, which applies to every step in this plan, and then each step has its own individual prompt. So these 4 layers are all concatenated together, and that's what the agent that does a particular step uses. So one thing I noticed is that the plan seemed to get stuck on this step. Now it doesn't show that it failed, but it's stopping. So this is a bug I'm going to have to iron out. One trick that I have figured out I can do is I can open up Claude alongside it and ask it, I think I asked, why did this fail? And it gave me this diagnosis. And what I'm going to tell Claude is do what everything is best. Also, I want you to resume the plan and periodically check on it. If there are problems, fix it with a subagent and resume until all is done. So I essentially will have the plan completed deterministically via Ralph, overseen by Claude. So we'll see how this goes. So here I am a day later, and the plan is completely implemented. Now, like I mentioned before, I was running into some problems with the Ralph itself, so I had Claude essentially monitoring it. One of the things that happened is my Codex subscription filled up for however the Codex handles their limits. So it switched a bunch of these steps to be implemented with Claude, and it added a bunch too with all the review stages, so much so that it kind of spills off here. So this is essentially what the completed plan looks like. Now I would like to improve my terminal user interface for Ralph so that it doesn't hide completely and I am no longer able to see everything that's off to the side. But it's usable, especially if you have a loop going on the side in something like Claude. So anyway, I will exit out of this now and we'll leave Ralph as well. See, in this we completed 150 steps out of 200. The parts that weren't completed were filled in by Claude. So now I'm going to open a new Claude session. And let's say, please install this version of LVIM on my system. So let's see what Claude does here and see what the output looks like and if it's a workable version of LunarVim. Okay, so this is not really working as expected. I cannot open my terminal. I get the sidebar here, which works as expected, but a lot of the keybinds seem to be missing. So it looks like my plan was implemented, roughly speaking, correctly. So the actual plan implementation side of Ralph seems to be working. It's really just the plan that needed more specificity. I'm going to call this video right here. It was unfortunately a little disappointing in terms of the actual planning of the Ralph, but at the very least, you can see the way that it goes through all these different steps of the plan, and it can use different, like for example here early on before Codex ran out, it can use Codex and Claude and switch back and forth between the two of them. And it's harness agnostic, so it can literally use any harness with any model.